Welcome to the Golden Software demonstration video for Voxler 2 Part 3. This demonstration video will cover creating and editing isosurface maps. Isosurfaces are three-dimensional shaded renderings from lattice files. The isosurface displays a constant value surface for a component. The isosurface separates regions less than the selected ISO value from regions greater than the selected ISO value. All points on the isosurface have the same value. To create an isosurface, load a data file and grid it, or load a lattice. Select the gritter module or lattice and choose Create, Graphics Output, Isosurface. Let's load a data file. Choose File, Load Data. Select the gold concentration.dat file located in the Voxler data directory. Click Open. The default settings are appropriate for loading the data, so click OK in both the Data Import options and in the Select Data Columns dialogs. The data appears in the network window. Click on the data file to select it. Choose Create, Computational, Gritter. Click on the gritter module to select it. In the Properties window, click the Begin Gridding button. When the gridding is complete, choose Create, Graphics Output, Isosurface. To change the properties of the isosurface, click once on it in the network window to select it. All of the properties are shown in the Property Inspector. The Connected To option shows the module name that is connected to the isosurface. The ISO value is the component value that the surface is showing. The generated surface separates data less than this value from data greater than this value. To change the value, click on the dragger and drag the bar to the left for a smaller value or to the right for a larger value. For a specific value, highlight the existing value and type a new one. Press Enter after typing the number for the value to take effect. The draw style changes how the isosurface is drawn. Click on the word Shaded to reveal the drop-down box with the other options. Shaded creates a shaded surface composed of small triangles. Lines creates the isosurface with only lines connecting the surface triangle vertices. Points plots a single point at each of the triangle vertices. The normal isosurface is shown with the draw style set to shaded. The side to draw changes the portion of the surface that is drawn. The face is relative to the camera position, so front displays only the front portion of the surface, back displays only the back portion of the surface. Front and back displays both the front and the back of the surface. The Smooth Normals option changes the look of the isosurface from a smooth surface to a faceted surface. Click in the box to turn on or off this option. When the box is checked, the surface appears smooth. When unchecked, sharp creases appear on the surface. The Color Method option changes the method of coloring that is used for the isosurface. Click on the By ISO Value text to change the method. By ISO Value sets the color based on the ISO value being displayed. When you change the ISO value, the color changes. Fixed sets the color for the isosurface to the same color, regardless of the value being shown. If you're showing multiple isosurfaces with different values, using the By ISO Value option with the same color definition will allow the colors to be represented by a single legend. When the color method is set to By ISO Value, the Color Map option is available. The Color Map allows you to map each value to a specific color. You can use one of the predefined color maps by clicking the grayscale color bar and choosing another color from the drop-down list. You can define additional color maps or change the properties of the currently selected color map by clicking the ... button to the right of the color scale bar. This opens the Color Map Editor. This dialog will be discussed in a future video. When the color method is set to Fixed, the Color option is available. The Color option sets the color of the isosurface regardless of the ISO value. This option is useful if you have several other maps and want to highlight a particular map in the group. To change the color, click the existing 50% black color box next to Color. a drop-down box appears. Select a new color and the Isosurface is automatically updated. To set a custom color, click the other box at the bottom of the drop-down box. A standard Windows Colors dialog appears. Select the desired color and click OK to make the change to the Isosurface. The Materials section contains options to change the surface appearance of the Isosurface. Click the plus sign next to Material to display the material options. The specular color is the color that is added to the specular highlights. The specular highlights are the locations on the Isosurface where the directional light hits and bounces off the surface. To change the color, click on the existing white color box. A drop-down box appears. Select a new color and the Isosurface automatically updates. To set a custom color, click the other button at the bottom of the drop-down box. A standard Windows Colors dialog appears. Select the desired color and click OK to make the change to the Isosurface. The Specular Intensity option controls how much directional light shines and reflects on the surface. Increasing the specular intensity results in strong shadow effects and more pronounced shiny or glare spots. Decreasing the specular intensity results in a dull surface. To change the specular intensity value, click on the dragger and drag it to a new value. Alternatively, highlight the existing value and type in a new value. The values range from 0 to 1. The Shininess option controls how shiny the surface is. Larger values display smaller and brighter, more focused highlights. Smaller values display less focused, larger highlights. To change the shininess value, click on the dragger and drag it to a new value. Alternatively, highlight the existing value and type in a new value. The values range from 0 to 1. The Opacity option controls the opacity or transparency of the Isosurface. The larger the value, the more opaque the Isosurface is. A value of 1 is fully opaque. A value of 0 is fully transparent. To change the opacity value, click on the dragger and drag it to a new value. Alternatively, highlight the existing value and type in a new value. The values range from 0, fully transparent, to 1, fully opaque. Finally, the Legend section controls the display of the legend. To display the legend, check the box next to Show. The legend is displayed. The Legend Properties section will be discussed in a future video. This concludes my demonstration of the Isosurface creation and properties in Voxler.